Let's look at number one first, because number one's pretty straightforward. And I think we did one similar to this last week. So here's the version I have. We have something like t squared times y double prime plus 5t y prime plus 3y equals 0. And they're telling us that y equal to t to some power of r satisfies this. I mean, I think I even saw something on Piazza how someone was asking about this question, and I think the teacher responded, pointing out that like the second derivative of t to the r is such and such. So yeah, so we're trying to figure out what values of r make this work. Sure, interesting. Okay, so we're going to do the usual thing. So whenever you're trying to see or show, see if something is, or show that something is a solution to a differential equation, you take all the necessary derivatives and you throw them into the thing. And then if you're trying to solve for something like r, you see what you're left with. So let's take this first derivative here, which is going to be r times t to the r minus 1. And then we'll take the second derivative. Same differentiating rules. We're just going to have that constant r out in front. The r minus 1 comes down, and the new power of t is r minus 1 minus 1, which is r minus 2. And then we're going to plug each of these things in to the equation above. So this is going to go in right there. This is going to go in right there. All that's going to go in right there. Something to notice when you do this is that all the powers of t are going to end up becoming t to the r, because you're going to have t to the r minus 2 times t squared, and t to the r minus 1 times t, and t to the r times no t's over here. So we're still going to write it all up, but it's good to see that we're going to get all of the same power of t. So I'm going to get t, let's write it over here, t squared times r minus 1 times t to the r minus 2 plus 5t times r times t to the r minus 1 plus 3y, which is 3 times t to the r equal to 0. Okay, so let's just clarify real quick here. There's my y double prime. There's my y prime. There's y. Now we should simplify and factor. So just like I said before, t squared times t to the r minus 2 is going to be t squared. So here I can write this as t squared. Sorry, t to the r, apologies. So I meant to say t squared times t to the r minus 2, you add the powers, you get r minus 2 plus 2, which is r. So t to the r times r minus 1 plus 5 times t to the r. I could have written the t to the r first, I guess, times r. And then finally, plus 3t to the r. And now I should do the sensible thing and factor out t to the r. If I factor out the t to the r, I'm left with an r times r minus 1, a 5 times r, and a 3. And then what we really should do is we should multiply this r times r minus 1. So we're going to get, that should still equal 0. So we're going to get t to the r times r is r squared minus r plus 5r plus 3 equals 0. And the rest of this becomes solving a quadratic equation. So we've got t to the r times r squared plus 4r plus 3 equals 0. And if they set this up nicely, it should factor. If they haven't, you have to use the quadratic formula. Here, this does factor. We can write this as t to the r times r plus 3 times r plus 1 equals 0. So what values of r solve this equation? Right. And that's it. So I want to point out, because some people might think there's some other solution here. There's no value of r that's going to make t to the r equal to 0 for every value of t. So that's the gist of this kind of problem. And then you had questions about 7 as well. Let's look at 7. 7 looks like I might not be able to answer part of it just because I don't know the answer. That's all right. We'll talk about it. So question 7 says, put the differential equation 9ty. I can number these. I guess I can number the other one too. Number 1. 9ty plus e to the t y prime equal to y divided by t squared plus 81 into the form. I feel like I missed. Nope, I'm not. It's just written really out of order. We want to write this as y prime plus p of t times y equal to q. They said g, fine. G of t, whatever. G of t, that's terrible. Anyway, okay, so we want to write this like that. So I'm just going to change the order of things first. So I'm going to write this as e to the t times y prime plus y times 9t, or 9t times y equal to y over t squared plus 81. And then I have to divide everything by e to the t. A little lot of focus there. Right, that's the only choice you have if you're trying to get this in that form. Y prime has to be isolated, and the only way to do that is to divide everything by whatever is multiplying it by. So if I divide by e to the t, it's not going to be pretty, but we're going to get y prime plus 9t over e to the t times y, and I might put that in parentheses, although you don't really need to, equal to y divided by e to the t times t squared plus 81. So if I were having to write out what p of t and g of t were, here is my p of t equal to 9t over e to the t, or if you prefer, 9t times e to the negative t. That's also a fine way of writing it. And here's my g of t. And you could either, I would probably write it like this, but you could also, if you wanted to, write it as y times e to the negative t over t squared plus 81. Oh no, I blew it completely. Why didn't you guys say anything? That's totally wrong. 100% wrong. So wrong. The wrongest ever. And the reason it's wrong is because exactly right. This thing on the right-hand side needs to be a function of just t and not y. So I totally blew it. And hopefully, if I was doing this, I'd be smart enough to be like, oh, I made a mistake. So I should have seen right here when I wrote this down, that should be g of t and not a function of anything but t. Oh, it's going to stop me from making those mistakes. So what we actually need to do is start over. Let's try again. So what we had was 9t, excuse me, y plus e to the t y prime equal to y over t squared plus 81. So we still need the y prime first. Yeah, interesting. I'm like, what do we do here? Okay, well, let's try and figure it out. So we've got e to the t times y prime. And I guess, I don't love this. I'm bringing everything else to the left so I can factor out a y. So I've got plus 9ty minus y over t squared plus 81 equal to 0. That seems semi-reasonable. I mean, I guess it kind of has to be if this is the direction we're going. So then we want to write this in the standard way. Let's first factor out the y from here. So we get e to the t times y prime plus y times something gross, 9t minus 1 over t squared plus 81, still equal to 0. And if we divide everything by e to the t, this seems weird. So divide by e to the t, and we're going to get y prime plus, well, I would take all of this, right? I wouldn't divide the y by e to the t. I would do the division by e to the t over here. So I would write this as y times, I don't love this either, 9t over e to the t minus 1 over e to the t times t squared plus 81. It might make sense to get a common denominator here. So this feels bad, but assuming we haven't made any dumb mistakes like I did before, it looks like this is going to be our p of t, which is awful. And this is going to be our g of t, which feels weird because usually the point I guess I'm seeing here is that you could make this separable. I don't know if you want to, it's probably awful either way, but I don't think we're being asked to actually solve it. So we're not too worried about that, right? Yeah. Because we're not being asked to solve it. Yeah, that seems kind of awful. I mean, it's not, I mean, I guess that seems like it would be awful if we had to solve it, but we don't. Yeah, good call on that. I was definitely not seeing it. You could simplify this further, right? You could get a common denominator. I don't think you need to. You might want to just for the ease of writing it in. But that's about it as far as I can see. Questions about this before I say anything else? Okay, so then it also asks, is it linear and homogeneous, linear and non-homogeneous, or non-linear? So first of all, is it linear or not? Yes, for sure. Because every y or its derivative only is raised to the first power and only is multiplied by functions of not y. Second question, and you guys will know better than I will, is it homogeneous? Okay, homogeneous. Why is it homogeneous? Cool. And specifically, at least I think this is what you all told me, it's when this standard form is equal to 0. Right? When you have the y prime. So yes, because we have something written in the standard first order linear differential equation form, because we have y prime plus p of x times y, or p of t times y equal to 0. Or in other words, because we've written it in the standard form and g of t is equal to 0. Okay, that seems fair to me. I guess I'm not so surprised about it being 0 then, because they're asking this sort of question. Cool, it worked out? Yeah. Right on, great. So it's ugly, but it's fine. Okay. Before I forget, I did find some old exams and kind of curated them a little bit. So if you want more practice, I've got some exams and also solutions printed up. Or if you are watching this video later and you want them, I will post them on Canvas, but here are solutions. I haven't looked at the solutions, so if you think there could be a mistake, it's possible. It's a weird staple that we have on our copy machine. Like it's like a yeah, I love it. It's my favorite. It's like I like it to make copies and they use the fun staple. It only works if you're making something with less than 5 pages or 5 pages or less. So I'm like, okay, how do I make it 5 pages? Anyway, I know it's the small things in life. So if you work on that and you find that there's something that looks suspicious, feel free to message me. I'll probably also look at it later just to kind of make sure the solutions look right. I'm pretty sure they're mostly right because someone posted them a while ago and probably looked at them just fine, but just take it with a grain of salt. I haven't looked over them to verify that the solutions are what they are. All right, so back to some reviewing. Let's look at what I've got here. We got all kinds of things. Let's look this way first. Yeah, where'd you go? There's one other thing here. Yeah, we'll do that too. All right, I'll watch my time. I'll kind of pick and choose here. So let's say we want to find some general solutions. So find the general solution of the following differential equation. Dy dx equal to x minus x y over y plus 1. This one is not printed very well. And at least to me, I'm pretty sure it's not going to be linear, right? Like even if you tried to multiply things around so you get y's and y primes by like separated, I just don't see a way of making that happen. This y over y here makes it feel like it's not going to be linear. So it's probably not first order linear, which means it's probably going to be separable. So if you can eliminate the linearity of it right away, you can probably, if you're actually being asked to solve it, deduce that it's going to be separable. If you're not being asked to solve, right? Like I'm imagine your teacher is going to ask you questions like, here are 5 differential equations. Is it linear, not linear, separable, first order, whatever? Like he's going to ask something like that. I'm pretty like looking at his practice exams, it seems pretty obvious he's going to. So definitely be ready for that. Here it looks separable, or at least it looks like it should be separable. So I'm going to try and separate things. And here on the right hand side, you can see, well, I can factor out an x. Usually, if you think it's going to be separable, once you've got dy dx by itself, you can either try to factor out an x to some power or a y. Like you can try and just factor out one of the two things usually. I'm factoring out an x. I'm left with 1 minus y over y plus 1. And before I separate this, I really don't want to I don't want to try integrating 1 over 1 minus y over y plus 1. That seems silly. I should try and simplify that. And I can't. I can get a common denominator here. So I can say that dy dx is equal to x times y plus 1 over y plus 1 minus y over y plus 1. Or if you prefer, dy dx equals x times y plus 1 minus y is just 1 over y plus 1. Well, that's going to work out pretty nice. I'm going to get y plus 1 times dy equal to x times dx. That's pretty good. So then we integrate both sides. I might do that over here. Integral of y plus 1 dy equal to the integral of x dx. So then we get y squared over 2 plus y equal to x squared over 2 plus constant. I will point out, sometimes your teachers will say a thing like, don't solve for y, or I feel like there was some language on, actually, I think there's some language on the thing I handed out, maybe. Maybe not. Oh no, yeah, like there's this question, this other one I have here. It says, find the general solution, don't solve for y explicitly, or you do not need to. And here, although it's possible to solve for y explicitly, it's not easy. I mean, it's not like super duper hard, but it definitely takes time. The only thing I might do here is multiply everything by 2. So I might rewrite this as y squared plus 2y equal to x squared plus a new constant. That's probably where I would leave this. If you really, really want to know, we can talk about how you solve for y, but I don't think you really need to know. I will tell you it involves using the quadratic formula, and basically, fine, I'll tell you. I won't do it, but the way you would solve for y here is you would write this as y squared plus 2y minus x squared plus c equal to 0. And then you do the quadratic formula and pretend like your a was 1, your b was 2, and your c was x squared plus c. Different c's there. I should use a different letter. Let's call that a k. And then you do the quadratic formula with that being a, that being b, that being c, and then your solution would be y equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. It's kind of weird, but it works. But not necessary. So if that kind of didn't make a whole lot of sense, I wouldn't worry about it. I assume your teacher hasn't talked about doing anything like that. Right, because you shouldn't. I mean, not that you shouldn't, but like, it's not that cool. Let's look at another example. Now we've got, what have I got here? Y times y prime minus 2 times the natural log of x over x equal to 0. Again, not linear. That y times y prime, I suppose unless you had like a y squared here and divide, so you could divide everything by y, that still probably wouldn't technically be linear, but closer, but definitely not linear. So I'm pretty sure, again, this is looking like it's going to be separable. Let's see. So let's try isolating y prime. So y times y prime equals 2 times natural log of x over x. And then I really just have to put the dx over on the other side, right? I probably should have actually written this as y times dy dx. So really, I'm going to have y times dy dx, but let's just write the dy part because we know we're moving the dx over to the other side. And I would probably write this as the integral of y dy equal to 2 times the integral of the natural log of x over x dx. So it wouldn't surprise me. In fact, I would be surprised if there weren't any U sub problems on your test, or like integration by parts seems less likely to me, but I have to imagine there's going to be at least one problem that will require you to do a little bit more than just it being a very straightforward antiderivative. So here is a pretty straightforward U substitution. We would let U equal the natural log of x. Du is exactly 1 over x dx. So the integral of the natural log of x over x dx becomes the integral of just u du, which is u squared over 2. What I recommend, though, when you see something like this, is since you don't want to like get caught up writing all of this u stuff with the like having all this other garbage behind it, I would do the integral of the u sub part off to the side, like I'm doing right here. Say, oh, that's going to be the natural log of x quantity squared over 2. Or I guess if you prefer, although I really don't, you can write this as the natural log squared of x over 2. So people write that. I really don't like it. It seems weird. It's kind of like how you write sine squared of x, is the same as sine of x quantity squared. I've seen this pop up more and more lately. If your teacher has done it this way, that's fine, but like it seems weird to me. I would just do this. I've got y squared over 2 equal to 2 times the natural log of x quantity squared over 2 plus c. And here, I would go ahead and solve for y because, right, we can. So I would say y squared equals 2 times the natural log of x quantity squared plus c. And then finally, without any initial conditions, we can only get to y equal to plus or minus the square root of 2 times the natural log of x quantity squared plus c. I will point out, if the problem says that you don't have to solve for y explicitly, right, it just says to solve the differential equation, but to leave it or to not solve for y explicitly, then you could and are probably encouraged to just stop somewhere like right here. Just like in the previous problem, we stopped before we could solve for y really. But definitely it's imperative for you to read the instructions, right? Make sure when you're doing the exam, you actually read what the instructions say and try to follow them to the best of your ability, right? Because sometimes they'll say things and you can stop somewhere sooner. Other times they're like solve it completely. And also there's this initial condition and you have to use that as well. All right. Look at what else we've got there. Yeah. I would imagine you will also have some particular solution type problems. I would also imagine there'll probably be a word problem, right? Like, yeah. Did he give you any kind of indication as to what kind of word problem or what kind of word problem it won't be? Yeah. Okay.
There will be a word problem. He said, but then he was like, the exam that you guys are taking is probably going to be a lot similar to the older ones.
Okay.
The older ones didn't have word problems on them.
Okay. So I would have to guess that the word problem, if there is one, won't be a tank problem because you haven't talked about them in class, right? And it won't be a Newton's law of cooling problem because you haven't talked about those either. So it'll be something that's more kind of made up, for lack of a better term, because not that they aren't all made up, but the tank problems and the Newton's law of cooling problems are very kind of a specific genre of problem. Whereas other things are just like you have the situation and the rate of growth of something is proportional to some other function of it. Let's do an example of that before we. So, right, I remember those. Here's an example that I think seems not unreasonable for a word problem. The rate of growth. So already when you read those words, you're thinking, okay, derivative of my function. The rate of growth of squirrels, or I should say really squirrel population, but fine, in the Arboretum is proportional to the cube root of the number of squirrels present. But yeah, I will just point out, because I'm copying this from somewhere else, this is not phrased in the best way possible. Because if someone said the rate of growth of squirrels, you might think about like how fast the squirrel's body length was growing, right? That's what that, right? But I should say rate of growth of the population of squirrels. Especially when it says it's proportional to the key root of the number of squirrels present, right? I mean, not that your body length growth rate couldn't somehow depend on how big the population was, but it doesn't seem very likely. So also common sense. Let's see here. Write and solve the differential equation for the number of squirrels, which we will call capital S, or you might choose to write it as S as a function of T, just so it's more obvious that it's your function present at any time T. And then we'll talk about some initial conditions. We'll talk about the initial condition part. Well, actually, no, I should write all that. If there are 8 squirrels present initially and 27 2 years later, how many squirrels will there be 12 years after there were only 8? Okay. So our differential equation, not too terrible. The rate of growth, okay, so rate of growth is ds dt, that's our rate of growth of the population, is proportional to the cube root of the number of squirrels. Great, so it's equal to a multiple of the cube root of the number of squirrels. There's our differential equation. Proportional to and the cube root of squirrels. Great, we can totally separate this. We do need to separate it, right? Because we want S's on the left and T's on the right. So we're going to rewrite this as ds divided by the cube root of S equal to K times dt. Or preferably, S to the negative 1/3 ds equal to K dt, because that's going to be much easier to integrate. Right, we don't want to write 1 over S to the 1/3. We want to write S to the negative 1/3. So now we're going to integrate it. So we're going to get S to the positive 2/3 divided by 2/3 is the same as multiplying by 3/2 equal to K T plus C. And here is my kind of general guideline for solving for this constant here. Well, actually, I feel like this is kind of 2 questions. So they ask us first to solve the differential equation for the number of squirrels, S is a function of T. And then they say initial conditions later. So I would probably actually just go ahead and isolate S completely before I start thinking about solving for the constant. So I was going to isolate S, I would multiply both sides by 3/2, which really, by 2/3, which really doesn't do anything, because 2/3 times a constant, still a constant. 2/3 times a constant, still a constant. So I think we can get away with writing this as S to the 2/3 equal to KT plus C. If you like, just to differentiate, I can call this K1 and C1 and this K2 and C2. And then we take both sides raised to the 3/2 power. So we'd write S equal to parentheses K2T plus C2 raised to the 3/2 power. And that would be our general solution. Now, let's go ahead and figure out what the particular solution is using the initial conditions we were given. Now, it is noteworthy that we need two initial conditions to be able to solve for these two constants, and we have them, where we know how many squirrels we have at time 0 and how many squirrels we have 2 years later. So that's what we're going to do. We're going to say, all right, we know that when time equals 0, the number of squirrels equals 8. And when time equals 2, the number of squirrels equals 27. Both notably being cube numbers, which is going to make this relatively easy to solve for K and C. Now, here's what I was going to say earlier before I kind of got caught with myself. Even though we want to solve for S as a function of T, if you know you have initial conditions to plug in and solve for the constants, usually this stage is where you want to plug in. Here is where I would try solving for C and K. Because it's kind of the least amount of work to do, right? You've already essentially, right, like when you plug in something for S or for T, solving for C or for K is really the least amount of steps after that. Whereas here, to solve for C or K, you'd have to go back and first raise both sides to the 2/3 power, which seems kind of silly. And doing it here, you both have to multiply both sides by 2/3 to eventually get there. So this is really the sweet spot. So when you're trying to solve for those constants, look for the place in the process where you've kind of got them almost already isolated before you've taken the square root of both sides or the natural log of both sides or done something weird where your constant's in a weird spot. Now, I will say an exception to that is like when you've got like an e to the something that you're undoing a logarithm for, you want to do the whole like e to the something plus something, and then the right, like you want to do the whole like the e to the kt plus c, and then you want to do a to the kt times e to the c, and then your a or whatever you're going to call it. You want to get to this spot before you start trying to solve for constants if you've got that kind of situation. Okay, years of experience, just one. Right, that's what I've seen over the years. That's generally the good place. So doing it here, by plugging in t equals 0, I'm going to get 8 and s equals 8. 8 to the 2/3 equals C2. Great, so that means C2 is going to be 4. And then plugging in the other one. Usually if you have a choice, plug in the one where something is 0 first. It's usually going to make it easy to solve for one of them. And then plugging in the other stuff, I'm going to get 27 to the 2/3 equals K2 times T, which is 2, plus C2, which we just figured out was 4. 27 to the 2/3 is 3 squared, which is 9. So 9 minus 4 equals K2 times 2. So 5/2 is equal to K2. So that means our particular solution is S as a function of T equal to this function, but with K2 and C2 plugged in. So it's going to be 5/2 T plus 4 raised to the 3/2 power. And if you're ever unsure about this, like you think, oh, I think I've got the particular solution, but I don't actually know, you can plug in your initial conditions and see if it works. If I plug in 0 for T, I get 4 to the 3/2, which is 8. If I plug in 2 for T, I get 5 plus 4, which is 9 to the 3/2, which is 27. So it should work out. Lastly, they asked us to figure out how many squirrels are going to be 12 years after there were only 8, meaning 12 years after time equals 0. So they're really just asking us, what do we get? What is the number of squirrels when time equals 12? So we plug in time equals 12. So S of 12 is going to be 5/2 times 12 plus 4, the 3/2. And so to his comment about like how much you need to simplify or not, here's how much I think you need to simplify for a question like this. We definitely know that 5/2 times 12 is 6. 6 times 5 is 30. Wow, I picked a number that worked out. How unlikely. So this is going to be 5 times 6 plus 4. Oh, no, it's not. I lied. It's not going to work out. Great. Better. Which is going to be 34 to the 3/2 power. And that's as simple as you can make it. But I do think right? This multiplication inside the 3 highest power is easy enough to do that I think we should. And then just to kind of ask all the types of questions someone might ask for a word problem like this. Another question one could ask is, how many years will it take to reach 1,000 squirrels? Assuming this model of growth is correct. Well, then we would just set the whole thing equal to 1,000 and solve for t. So I'd have 5 halves. Oh, I picked a good number. I think I picked a good number. Well, or maybe I didn't. I picked a number that's going to require us to simplify, in my opinion. Because if we raise both sides to the 2/3 power, we have 5 halves times t plus 4 equal to 1,000 to the 2/3. And what's the cube root of 1,000? Right. And 10 squared is 100. So this is really 5 halves t plus 4 equal to 100. Which I think, I don't know, it's not terrible, but fine. So then we subtract 4 from both sides. You'd have 5 halves equal to 96. And you multiply both sides by 2/5. 5 halves t, sorry. And then finally, t would equal to 96 times 2/5. And I might leave that. Or you might write it as 192/5. Years. So I don't know, like almost 40 years. Okay. But again, right? Definitely the simplifying is, in my opinion, you should get the least of your focus. Right? Like if you're doing a problem and you're like, well, I know I could simplify that, but I've got other problems to work on, go work on those. And then if you have time, come back. But if you don't, an unsimplified answer is better than leaving some other answer blank. Okay, let's look at more. Sure, let's look at this example. Find the particular solution of the differential equation x squared y prime plus x times y equal to 1/x with the initial condition x equals 1 and y equals 2. So to me, this is written in a way that's suggesting first order linear, right? It's definitely written patterned that way. We just don't have it quite right. Now, it's possible that you could separate this. I don't really think we could. But if something's written in a way that's suggesting first order linear, I would encourage you to explore that path first. Because it usually people aren't trying to trick you. So if something's written as a something y prime plus something y equal to some function of your other variable, try to make it look like your first order linear, meaning we want to isolate y prime. So divide everything by x squared. So y prime equals plus x over x squared times y equal to 1/x over x squared. Yes, I know I can divide each of those things by x squared, but it's good to at least think about what you're doing. I'm totally fine with you not writing this step, but I just want you to make sure you're being thoughtful about, oh yeah, I'm doing that. So y prime plus 1/xy equal to 1/x cubed. And then he's totally cool with us just finding the integrating factor and jumping to the end. So let's find the integrating factor. So integrating factor, that's going to be mu of x or u of x equal to e to the integral of 1/x dx. Does he, I don't think he wants you to write the opposite values, right? He's definitely, yeah, okay, cool. This to be e to the natural log of x, which is just going to be x. We should do one like that if I have time. Great. So my solution is going to be y as a function of x equal to 1/the integrating factor times the integral of q of x or g of x, if you call it that, times the integrating factor. I do think it's worth writing this out unless it's already given to you in the exam, just because so that he knows, or whoever's grading knows, oh, look, they know what they're doing. They know what the formula is for that. And then actually plugging things in. So then that's going to equal 1 over x times the integral of q of x is 1 over x cubed times mu of x, which is x. So then we simplify the integrand. I would choose to write that as the integral of x to the -2, which is going to give me -1 over x, or x to the -1 over -1 plus c. So our general solution is y as a function of x is equal to 1 over x times -1 over x plus c. And if we want to find the particular solution, plugging in our initial conditions, we're going to say, okay, well, then we're going to get y of x is 2 equal to x is 1. So 1 over 1 times -1 plus c. So it looks like c needs to be 3, right? 2 equals -1 plus c. So 3 equals c. So my actual particular solution, same answer, just plug in your value of c. So y as a function of x is 1 over x times -1 over x plus 3. There are certainly other ways to write this. But again, if you're strapped for time, this is a totally fine answer.
This is also what I meant by he wants us to simplify the question. Like, would he want us to multiply out that 1 over x? I would think no.
Yeah, I don't know.
But I mean, also, my brain just naturally, after I.
I certainly want to multiply that and write it as -1 over x squared plus 3 over x. That's what I would want to write as my answer. But I think you'd be perfectly fine with this. Unless he says you're not. I know, super helpful, right? Let's see what else we got. We don't have that much time. Since we don't have very much time left, let me just address one thing that I want to point out, which I think is worthwhile. No, not you, not you. Sure, let's look at, yeah, this is a great, here's a perfectly good example. Let's say we've got this, I'm going to change it up just slightly here. Let's say we've got the following first order linear differential equation. Sine of x minus, sure, that seems dumb, fine, whatever. Minus, y prime times sine of x minus cosine of x times sine of x times y equal to sine of x squared e to the sine of x. Okay, this one's not that exciting. At least it's not that exciting because clearly someone just like, I took a first, literally someone being me, I took a first order linear differential equation. I multiplied everything by sine of x to make it more complicated. So clearly here we have to divide everything by sine of x. So step 1, divide by whatever is multiplying y prime. It's not the, okay, so we get, in this case, sine of x. So dividing everything by sine of x, no big deal. You get y prime minus cosine of x times y equal to x squared e to the sine of x. Okay, now here is the big deal. When I find the integrating factor, this is what I want you to be careful about. My integrating factor here is going to be e to the integral of what?
Negative.
Perfect. Yes, exactly. The negative sign is what I really want you to be focused on here. It's easy to miss. So make sure if it's a y prime minus a thing, that negative sign goes along with your p of x. Good job. And then the antiderivative of negative cosine is negative sign, I think. Right? I think. Yeah, that sounds right. Okay. So you e to the negative sine of x. That seems terrible. But it's actually great. If you're solving this, our solution now, and I'm just going to jump straight to it because it is 1050, is going to be 1 over e to the negative sine of x times the integral of x squared times e to the sine of x times e to the negative sine of x. Well, that's great because those two things multiply together to give you 1. So really what we've got is 1 over e to a negative power is the same as e to that positive power. Something like this is e to the sine of x times the integral of x squared, which is just going to be e to the sine of x times x cubed over 3 plus c. And since they didn't give us any initial conditions, there's our answer. But the thing I really wanted to emphasize there, which you both caught perfectly, is just look out for that minus sign there. It's an easy